I did a build today with a friend of mine. We put this RedRotor Pro Mini OSD into his ZMR 250. And I just wanted to walk you through some of the things I noted during the build. This first picture is the PDB slash OSD sitting on the frame. It's a standard 36 millimeter size, so it really shouldn't, the scale shouldn't really surprise you. One of the things that we ran into was that since he had cut his ESC wires for an existing PDB, they wouldn't actually reach the pads on the Pro Mini. If you look right here are the pads for the Pro Mini OSD, and they're all the way over at one side. So the wires were cut for a PDB that had pads at the diagonal corners, and a couple of them would have just barely reached, but several of them wouldn't have reached at all. So we had to replace the wires on the ESCs. If you are going to do a build with this OSD, and if you've got your ESC wires cut exactly to length, you may run into that. It's not the end of the world, but it is something to be aware of. Here you can see that the pads, the positive and negative pads for the ESCs, are on both the top and the bottom of the board. So that does make life a little bit easier. Please ignore, we've got some messy solder here. That's us. We put that there. That didn't come, the board didn't come like that. So you can put the wires both on the top or the bottom or both. If in our case, the only kind of silicone wire we had handy was actually 14 gauge, which is a little bit thicker than is really needed. So it was a little bit tricky getting it to fit here on the pads. And if you look, you can see we ended up putting 2 on the bottom and 2 on the top, which gave us a little more room to work with. And we didn't have any problems doing that. I was a little bit worried that possibly when we soldered the top ones on, the bottom ones would come desoldered, but we were just a little careful with the heat, and it wasn't really an issue. Here we've got the PDB set down into place with the 4 ESC wires connected. One of the things I wanted to make sure to do was to test the output of the voltage regulator. Just for the record, I want you to see that my multimeter is reading 0.06 volts higher than this battery meter. Okay, so my multimeter reads 0.06 volts higher, just a little bit, but just want to make sure you're aware of that. If we then check here, I am measuring the output of the battery voltage pin on the video transmitter header. We're feeding it with a 4S battery, 15.63 volts. And if you take into account the 0.06, that's 15.69. And we're seeing here 15.39. There is a small amount of voltage drop due to the filter on the board. So that is, everything is as it should be here. When you compensate for the small amount of difference between my meter and this little battery checker, and then the few tenths of a volt drop through the filter, okay? Now here we're feeding the PDB with a 3S battery. No, sorry, this is a 4S. Here we're feeding it with a 4S, 15.63 volts going in and 11.97 volts coming out. This is on the 12 volt pin. So that is, again, all as it should be. And here I'm feeding it with a 3S battery at 11.23 volts. The way this regulator works, this is an LDO regulator, and the way this regulator works is that when the input voltage goes below the dropout voltage, so I don't know what it is for this regulator, but if it was a 12 volt regulator, typically you would need an additional between 0.2 volts and maybe 1.5 volts, depending on exactly what type of regulator it was. So basically, when the input voltage gets very close to 12 volts, then this regulator basically just passes the voltage through. So this is a step-down regulator, but it is not a boost buck regulator. In other words, you will not get a reliable 12 volts out of this once your input voltage goes below 12 volts. And you can see here the battery is at 11.23, which if you add the 0.06 to bring it into line with my multimeter, that's 11.29, and we're reading 10.92. So again, we're dropping a few tenths of a volt going through the regulator, or rather through the filter, and then the regulator is just passing the battery voltage through. Now this shouldn't really be a problem, and in fact, in some ways it's beneficial. I say it shouldn't be a problem because anything that's designed to run off of 12 volts should be just fine down to at least 10.5 volts. And if you're running a 3S battery and you're going much below about 10.5 volts, you may run into trouble anyway because you're kind of abusing your battery. That being said, if you were to run a 3S battery all the way down, I mean, you could theoretically run it down to 9.6 volts, and that would be still technically above 3.2 volts per cell, and technically be a safe thing. Your battery wouldn't last long if you did it regularly, but it wouldn't be dangerous. If you were to run a 3S battery down to 9.6 volts, you might have a 12-volt appliance that wouldn't like that very much. But if you look at most of the, if not all of the video transmitters and other devices that we're using that we might be running off 12 volts, many of them will be rated down to 2S and they'll be fine. On the other hand, if you have a camera that's 12 volt rated, and you're probably going to want to check to be sure if it's okay down to, let's say you run your battery down to 10.5 volts, and then you're losing, it looks like about 0.3 volts, so now you're down to about 10.2 volts. You would want to check to make sure that your 12 volt camera was okay down to that voltage before you got up in the air, you ran your 3S battery all the way down to nothing, and your camera cut out. On the other hand, if you're running off of 4S, this is not going to be a problem because you will always be above that 12 volt cutoff voltage for the regulator. And here you can see the resulting stack with the OSD/PDB on bottom and then the nays on top, and they are placed inside the ZMR but there's actually a little more room to spare than it looks like. We used the kind of standoffs that we had handy, and we could have squeezed it a little tighter with a little bit different size of standoffs, but still plenty of room to spare there between the nays and the top of the frame. And here's a view from the other side. Here's the button that you would press to configure the menus and do the very basic configuration that's necessary for the ROSD. Again, you can see plenty of room here, plenty of breathing room for the OSD and the nays. The main place that we could have saved space if we had really wanted to was we raised this board up a little higher to be able to get extra room underneath for this thick 14 gauge wire, which again we used just because that was all we had on hand. But if we had been using something like 18 gauge, which would be 16 or 18 gauge, would have been more than fine for these ESCs. We would have had a little more room and could have used a shorter standoff and had a little more space here. But even as it is, it's just fine. So here I'm just going to walk you through the OSD menu very quickly. There are really only a few menu items, 5 menu items to go through. There is the RSSI minimum and maximum, which are the first 2 items. You set these by, oh, first of all, you enter the menu just by holding down the button on the PDB for 3 seconds after powering it up. So you hold the button down, you power it up, and then keep holding it for 3 seconds, and it enters the menu. There are 5 menu items, like I said. RSSI min and max are the calibration for the RSSI output. In this case, we're using a D4R2 receiver, and it has, I think it's analog RSSI out. The PDB can take both analog and PWM RSSI out. It has a filter on it, so if it'll convert the PWM to analog if that's what your receiver outputs. Doesn't matter. And you just use the calibration here to set the min and max voltage that the PDB should expect to see. And the way that works is you calibrate the minimum by just turning your transmitter off, and you press the button and it calibrates the minimum. And then you turn your transmitter on and you calibrate the maximum. You turn the transmitter on with it right up next to the PDB, and that's how you calibrate the maximum. So very simple, very easy to do, and once it's done, you're good to go. You can calibrate the voltage. This was within 1/10 of a volt of my multimeter, so very close to accurate. If you want to, you can calibrate the voltage. We didn't need to do that though, it was good enough. And you can calibrate the battery warning level. It comes preset at 14 volts for 4S. You can set that to whatever you like. The only downside here is that if you do need to go through 3S, you got to hold the button down for a long time while it rolls over to the other side. So it's a little bit annoying there, but again, you'll only have to do this once and then you'll be good to go. And that's it. You're done. That's all the calibration. Would take you a couple minutes at most when you first power the board up, and once you're done, and then you never have to do it again. It's all accessed through a single button. You press the button once to perform the function, and you hold the button down to move through the menu items, or maybe vice versa. I can't remember which, but basically just one button does it all. Finally, I'd like to just show you some flight video. You can see how responsive the OSD is during flight. You can see how it deals with, the different background lighting or colors of scenery and how readable the lettering is. And also at the end, we do a little run up to show the going up to, I think it goes up to about 96 amps. These are 2205 2350 kV motors on 4S with 6045 props. And we actually ran them up with an 1800 milliamp hour battery and only pulled about 65 amps. So we tried a 2200 milliamp hour battery and we hit 96 amps. So immediately you can start to see the utility of some of this in terms of being able to see if your battery is giving you the performance you need, and also just in terms of we could see that it pulls 96 amps here on the ground, but then what does it pull once it's in the air and the props unload? That's the kind of information that is really hard to get without an OSD like this. So I'm going to go out with these videos. I'll leave you with them, and really happy with this product so far. Obviously, time will tell how durable it is, but so far, in terms of clean install, ease of setup, ease of use, the product is delivering what it promises. So, all right, I'll leave you with these videos, and as always, happy flying, and I guess happy building.